The question here is to evaluate sine 75 degrees. So far we know how to evaluate sine 30, 45, 60, etc. because we have the table, and sine 75 we can evaluate by looking at the book of sine tables. But here we would like to find sine 75 without looking at the sine tables. We just have our table of values 0, half, 1 over root 2 for 0, 30, 45, etc. So just from that table, how do we find out sine 75? We want to write it in terms of sine or cos of angles which we already know. And 75 we know is 30 plus 45. So we have here a compound angle 30 plus 45. Now sine 30 plus 45 is sine A plus B, that is sine A cos B plus cos A sine B. So let's write that down. Sine of the first term, cos of the second term, plus cos of the first term, sine of the second term. Now since we already know sine 30 is half, cos 45 is equal to 1 over root 2, cos 30 is root 3 by 2, sine 45 is 1 over root 2, we get the answer to be 1 plus root 3 over 2 root 2. Now in this problem, sine A is given to be 1 by root 10, sine B is given to be this, A, B and A plus B are given to be acute. Show that A plus B is equal to 45 degrees. Now in this case, we can draw a triangle. We draw the triangles in the first quadrant because A and B are acute. So let me draw the second triangle also. So here we have A and B. Supposing the angles are given to be between 90 and 180, then the triangles would have been in this direction. Note that the perpendicular is always perpendicular to the x-axis. And similarly, if it was in this quadrant, the triangle would have been like this, where the perpendicular is perpendicular to the x-axis. If it's in the fourth quadrant, the triangle would have taken that shape. But right now the triangles are in the first quadrant. Sine A is equal to 1 by root 10 opposite over hypotenuse, and so opposite is 1, hypotenuse is root 10. In the second case, sine B is opposite over hypotenuse, that is 1 over root 5. Opposite is 1, hypotenuse is root 5. Now we have to find out the third side in each of the two triangles. The third side is equal to hypotenuse squared, that's 10, minus side square, that's 9. Square root of that gives us 3. Similarly, hypotenuse squared 5 minus 1 squared, that's 4, square root of that gives us 2. Now we can either find, we've got sine B, so we can find cos A and sine A, and we can use sine A plus B, or we can find tan A in both sides, and we can use the formula for tan A plus B. Now if you notice here, tan A is 1 by 3, so since there is no root in that, we shall use tan A plus B. So first of all, we need tan A. Now tan A from the first diagram is opposite over adjacent, that's 1 by 3. From the second figure, tan B is equal to opposite over adjacent, that's equal to half. Now we know the formula tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. So all that remains is to write down the values here, just substitute them. 1/3 plus half over 1 minus product of 1/3 and half is 1 by 6. Now when this is worked out, we get 5 over 6 divided by 5 over 6, that's equal to 1. Now if tan A plus B is equal to 1, it means that A plus B is therefore equal to 45 degrees, and that's what we have been asked to prove.